Here I'm going to show you how to set up the heatsink model in ANSYS and solve it. So we'll drag steady state thermal into the project page. You can rename this. I won't do this in the interest of time. And the geometry is given as a download, the CAD. And so you need to download it from the web page and then upload it to, if you're now Apps on Demand, upload it to Apps on Demand using My Files. So you can use My Files, go to Temporary Files, and then use Upload Files, and you should then have this, this CAD file, which is in the space claim format. And then I can right click, say Import Geometry, and browse. I'll go to this PC, temporary files, and I see that CAD file, and I'll open. And that's all there is to the geometry steps. So let me start mechanical. I'll say right click on model and say edit, and it'll take a minute or so to come up. So take a few deep breaths, relax, don't check social media. Once it comes up, you will see the tree being populated, and under geometry, you see I have one, volume, and then that's divided into 3 regions. So you can think of this as this, the top one is the domain over which we want to solve our governing equations. And then that's the domain is divided into 3 subdomains where we are going to give different k values, for instance. You can rotate using the middle mouse button, and where you hold down where you find the red ball, that's the center of rotation. You can also use these options to manipulate the model, the rotate and the pan. And if I translate using control middle mouse button, I can highlight these different regions of the model. So fin is shown in green. This is what we're using to dissipate the heat from the LED. The LED is in the front, and then the interface is between the LED and the fin. Okay, so we want to specify the governing equations. Now these equations are turned on by default when we drag steady state thermal. So all we need to do is specify K and Q dot. Let's specify K first. And to do that, I will go here and I'll go back to the workbench window using this option. I'll go here. I'll go into engineering data by double clicking it. Go to the engineering data tab. I will add a new material, aluminum, and enter. And I want to give isotropic. So under thermal, you might see only thermal. I was playing around with this and drag isotropic thermal conductivity onto aluminum. And the value is 189 watts per meter per Celsius. Enter. Okay, and then I have the interface material. So I'll add a second material. Interface, let me spell that right, or with no capital in between, and then again I can drag isotropic thermal conductivity onto interface, and the K value for the interface we are given is 48 watts per meter per Celsius. Okay. Now, if I go back to the project page, it says, hey, upstream, there's been a change. Do you want to bring it downstream? So right click and select refresh. Don't select update. You might go into an infinite loop. So the refresh will bring it into the the mechanical window. So I'll go back here and then go to mechanical. And now if I go to fin, for instance, I can, and under material assignment, I will change it to aluminum. Similarly for LED, I'll change it to aluminum. And then for the interface thermal, I will change it to the interface. And under materials, you can check that the values are right for aluminum and so on. Okay, so that's so now it has the right values of K, and K is different in different regions of the model, and we are only left with specifying Q dot, which is the internal heat generation. So let's do that. For that, I will go under steady state thermal, and I will go to heat and say internal heat generation. And the heat generation is only over the LED region. So I'll say body selection, LED, that's this part over here. And I will say apply. And the value I will use in this demo is 2×10⁻⁷ watts per meter cubed. And if you need to find any options here, you can go and search in the quick launch window. Okay, so at this point, if I go back here, we have specified the governing equation by dragging in steady state thermal. We have specified K, and we have specified Q dot. So the governing equation is defined, and let's specify the boundary condition next. And before we do that, let's save the project. So I'll go, in fact, let me do that in the workbench window. I'll say File, Save, and then I will call this heat_sink and put it in temporary files. And if I go into File Explorer, for instance, I can look that it's created the WBPJ and the associated files. At this point, I might want to save it in the WBPZ format too for download. So I'll say File, Archive, and see, that'll give me the WBPZ, the Z being for zip. So it'll zip everything and give you a single file. I'll say I want to archive everything, and you can download that to your local computer, for instance.